Here's a complex fraction to simplify. The first step is always to identify your LCD. My LCD in this case is going to be the product of each distinct factor. I have an x minus 5. I technically have two of them, but since there's only one in each denominator, I only need one. Also x minus 2, and finally x minus 6. The second step after we find the LCD is clear fractions. Let's multiply this LCD by every term or every fraction in this complex fraction. So I will multiply the first fraction by my LCD, the second fraction by my LCD, the third fraction, and the fourth fraction by my LCD. And it's important that you really multiply every term. Remember, basically what we're doing is we're multiplying top and bottom by the same expression. Do you remember the saying, what you do to the top, you have to do to the bottom? That's what we're doing. We're making an equivalent fraction, and in doing so, we're able to cancel out our denominators. So for example, if you look at the first fraction, we get the quantity x minus 5 and the other quantity x minus 5, which is in the denominator, to cancel out. Don't know if I can actually put a line through this, but I'll let you take my word for it that I'm actually going to cross cancel these or cancel these out. So my step number 2 again was clear fractions. Oops. My next step after that will be to cross cancel, or I'll say simplify. So I'll take this whole thing and I will cancel out again. The x minus 5 cancels out this x minus 5, leaving me with just the 6. The x minus 2 here will cancel out with this x minus 2, leaving me with just the x. In the denominator, the x minus 6 will cancel with this x minus 6, leaving me just with a 3. And the x minus 5 will cancel with this x minus 5, leaving me with just the 2. Simplify a little bit more. And every once in a while, be careful, because what we might be able to do is factor the top and factor the bottom. Now, a lot of people would be tempted to actually FOIL or distribute the top or bottom out, but if you look real carefully, you might see a greatest common factor. I see it. Hopefully you do too, and I'll show you right here that on the top I've got an x minus 6 in the first term, I've got an x minus 6 in the second term, so that's my greatest common factor on top. I'm going to factor it out. When I factor it out, I'm left with on top 6 times the quantity x minus 2 when I rearrange it, plus x times the quantity of x minus 5. And on the bottom, I am looking at a greatest common factor of x minus 2. Again, we see an x minus 2 in this term and an x minus 2 in that term. So when I pull it out, what am I left with? I am left with, looks like 3 times the quantity of x minus 5 minus 2 times the quantity of x minus 6. Great. Now nothing cancels yet, but now at this stage what we will do is we will distribute the insides of those brackets and combine like terms, refactor it, and see if anything else simplifies. So the next several steps are just keep simplifying until you see some magic happening. So let me copy this. Distribute the inside. I will get 6x minus 12 plus x squared minus 5x. And on the bottom, when I distribute out the bottom, I will get 3x minus 15. Watch out for that negative 2. When I distribute the negative 2, I will get negative 2x plus 12. Simplify a little bit more. I'm going to put an equals there and just simplify this way. So I still have my x minus 6 out front. I will take the x squared, move it in front. 6x minus 5x is 1x. Don't forget the minus 12. Oops, I forgot the positive in front of the x. Since it's a positive 1x, I'll put a plus. On the bottom, keep the quantity of x minus 2. And then 3x, take away 2x is 1x. And negative 15 plus 12 is minus 3. Almost done. Just simplify this a little bit more. And what you'll see is that something miraculous might happen. Since I do have a quadratic expression on top in the brackets, I will factor it as x and x. And 4 and 3 will give me 12. But since I want a positive x in the middle, I'm going to say positive 4 and negative 3. And in the bottom, I have x minus 2 and x minus 3. And hopefully you'll see that the x minus 3 on top and on bottom will cancel each other out, thus leaving us with a final answer of x minus 6, x plus 4, all divided by the quantity x minus 2. That is our final answer. You can distribute the top out if you'd like to, but honestly, it's probably easier to leave it like this, because in a future chapter, we'll look at zeros and asymptotes and other elements of a graph. Hope this helps.